One of the important topics in real projects is exceptions and exception handling. So let's know about that. During our programs, we create several bugs. We already learned about bugs and debugging before. So bugs are there, no way to skip them. We should differentiate between what is a syntax error and logical error. The syntax error, as we learned so far, is something that is checked before running your program mainly. Or it could be, for example, missing a parenthesis here, like here, maybe this line number 3 has two syntax error. It merely has a missing parenthesis and also it has an indentation problem. So this is mainly the syntax error. You didn't respect the statements of the language. The logical error, and also we know it so far, is an error happening during the runtime of the program. Something like division by 0, accessing an array with an invalid index. When these errors happen, we call them exceptions, and we need to handle them in a proper way. Let's give an example of a logical error. Let's read this code. Take a minute to read it. In this code, we have a function read integer. It takes a message to print it, take a string from the user, cast it to integer. But the problem with this code is, if the user didn't enter an input integer, it's going to fail with a value error because we failed to cast or convert hey to a number. We don't write such a code in production. The word production refers to the code that we eventually put to the running of the application. So we develop our code, and once it is done and well tested, we put it in our servers for the customers to use it. Now, the users might abuse our system, might use it wrongly. There might be hackers who would like to get our service down. We cannot depend on the customer or the correct input coming from us. There is what we might call blocking errors. By that we mean that we are facing an error during the processing of the function and we cannot proceed anymore. Sometimes maybe creating a big list would make a huge memory and the system will fail. Sometimes you are trying to open a file that doesn't exist, or maybe there are permissions on it. So you cannot access the file and you cannot continue processing. Sometimes you are making a remote call connection, but then some disconnection happen in the remote call, like maybe the system there shut down. Let's say you are doing a payment system and you are paying a bill for a customer, but the money is negative value. So someone is asking me to pay -10. Something is wrong with the input. I cannot do that. You would like to compute square root x, but x is negative value. This is wrong. You cannot compute a square root of a negative value. And also we definitely could have a lot of coding mistakes, like maybe accessing array out of the boundary of it. So in this kind of cases, we typically cannot continue processing. We have to stop. But also we would like to communicate this problem to others. Maybe they could handle it. But anyway, for us, we cannot proceed with that. There are two major approaches when it comes to handling this kind of blocking issue. The first one is called returning error codes. We start to build our internal database and not a database, let's say a file. And I started to say this error code number means this case. For example, 0 means we are success, 1 means invalid URL, 2 means something, and so on. Something that we as a team agree on it. And if we have a problem in our function, we return an error code to the caller. This approach is popular in Python, and even many other programming languages to a large extent is abandoning it. The common and standard way is throwing and handling exceptions mechanisms. These mechanisms let us stop at this point the function processing and let us also handle the issue that happened. And this would be the case of the next video. For future reading, you might read about error codes versus exceptions. It's very common in domain like C++. I would like here just to show you that we can raise an exception by ourselves. Let's say someone have a function f that take a value, and would like to stop the processing at all if the value is less than 0. So you can use the following syntax. You use the keyword raise, then you can use one of the well-known exception classes like value error. We saw a lot of that. Now we can use it, and we are providing here a message. If we try to run this code, it will give us this message here, value error -10 is negative value. So this is how we stopped the processing inside the function, by raising or throwing an error. And we use the value error, which is a built-in class for one of the exceptions. And the next time we'll learn about how to handle an exception when someone raise it. That's all.